So the standard problem that's been given to animals to test whether they understand something about the causality of their tools is this: it's the trap tube. So what you have is a horizontal tube, and an animal has to avoid pushing food towards the trap, and instead it has to pull it away from the trap to get the food out. And what we do is we give them lots of experience with this trap tube and blocks of 10 trials, and we randomly reverse the position of the trap, which means that they can't learn to always just come from one side and pull, because sometimes the trap's going to be on this side. So what we did was present our crows with this initial tube, and we found that out of 6 crows, 3 were able to learn to solve the problem within 150 trials. So we want to know now, how are they solving the problem? So we change the characteristics of the trap tube to begin with. First, in our first transfer, we took away the discs, just leaving the blue rim. So now the crows have to pull away from the blue rim, but these 2 arbitrary cues here that don't mean anything have now been removed. So if they just learnt to do something because of learnt associatively about one particular arbitrary cue, then they should fail. And we find that these 3 crows continue to avoid the trap. So okay, they could still obviously have been using the blue rim, that's still there, and it's a very obvious cue to use to solve the problem. So in our next transfer, we remove the blue rim and we put back the discs, but this time the discs are black. And we find that again the crows continue to solve the problem. So at this point we thought, oh, there's something maybe interesting going on here, you know, because they're not using any single cue, any single feature of the problem in order to solve it. However, they still could have been using kind of 2 cues independently. So if they'd learned both about to like pull towards this disc and pull away from the rim, if these were independent cues, then when we take away one, they've still got the other one which they use, and vice versa for those 2 transfers. So then we put 2 holes into the tube, and we put a trap base to only one of them, because we wanted to see whether the crows would prefer to use the obvious cue, the trap base, which had remained, or if they were confused by the 2 holes, because the holes are kind of causal features. They're an important part of the problem because they actually do something. So what we found was that when there's 2 holes there, the crows got really reluctant to pull the food into either of the tubes. So they were either of the holes, sorry. They were really reluctant to pull the food into either of the holes, so they spend a lot of time pushing to here and then coming back and moving the food to here without pulling into either hole. So this suggested to us that they really kind of learned something about holes, either that they just learnt to avoid them, or maybe they've learned something more interesting. Maybe they'd actually learned like a regularity in the world, that maybe objects only move horizontally along a continuous surface. So then we gave the crows the trap table. Now this problem looks completely different from the trap tube. It was a wooden box with 2 pieces of food in, and there was a trap, a hole in front of one of the pieces of meat, and there was a continuous surface in front of the other. Now the trap tube differed in the material. It was made out of wood, this is made out of perspex. It differed in colour. The trap tube is brown, this is obviously see-through, and it differed completely in shape as well. This is a circular tube, and the trap table was a box. So the ability to kind of transfer knowledge when there's no perceptual cues, when there's no visual cues that are similar, is kind of has been used in our field as a nice test of kind of higher cognition, because maybe it's requiring some abstract concepts there of what a hole is. It's not just a circle in a perspex tube, but it can be all kinds of different shapes and sizes. The important thing is the hole. And when we gave the trap table to our crows, really surprisingly, from the very first trial, they were avoiding it. All 3 crows on their first trial avoided the hole, and they continued to do so. And this was, as I say, surprising, because that kind of suggests that what the crows had actually done was extract some kind of causal regularity, that they'd understood some kind of rule in the world, that objects will only move along a continuous surface, they won't move along a hole in the same way. So what that leads us to suggest is that right from the very first tube, they were using this kind of causal relation, and they used this causal relation across all the permutations that we gave them of basically understanding something about the whole, and that then in order to have transferred to the trap table, they must have been using analogical reasoning. What our results really aren't saying is that the crows think in exactly the same way as humans. What we found was that they seemed to understand something about how holes work, but on our third transfer I mentioned that when there were two holes, the crows got really confused and they didn't understand that one hole had a base and one hole didn't. So a human, if you give that problem to, they're going to say, oh, I should pull it out this way because it's going to fall through the hole, and I get it. The crows didn't do that. A study this year gave 20 individuals from the great ape species, so bonobos, chimpanzees, gorillas and orangutans, and they gave them the trap tube and then looked to see if they could transfer to the trap table, or vice versa. They first learnt about the trap table and then they transferred to the trap tube, and they found no evidence of transfer. That even though the apes could get really good at this, when you give them a trap table problem, they go back to putting it in the trap all the time. So our crows have really shown a level of sophistication here that hasn't been shown before,